Hey everyone, and welcome back. Ready for another deep dive?
Always ready to dive in.
All right, awesome. So today we're taking a look at exponents.
Yeah, it looks like someone's been sending us quite a few notes and excerpts all about powers and exponents.
It does seem like someone's getting ready to really tackle this topic, maybe even dip their toes into exponential growth and decay, which can be a bit tricky, to say the least.
Oh, absolutely. But, that's what we're here for.
Exactly. We're going to unpack all of it, break it down, make it, make it make sense.
Yeah, and not just, the what of exponents.
Yeah.
We'll get into the why. Why do they matter?
Exactly. So let's see. Looking through these notes, I'm seeing properties of exponents highlighted a bunch. Sounds a little mysterious, don't you think? Like some sort of secret code.
Well, they are pretty essential. I mean, if you want to simplify expressions or, solve problems with exponents.
Right. So are they like actual rules, like hard and fast rules you got to follow?
They're definitely rules, but I wouldn't say they're arbitrary. They reflect some pretty elegant mathematical concepts.
Okay. I like where this is going.
For instance, the product of powers rule.
Okay. Hit me with it.
So it basically says x to the power of m times x to the power of n equals x to the power of u, ready for this m plus n.
Whoa. That's a lot of letters and numbers all at once.
Right, but it's not just a formula. It's like it shows how multiplication and exponents are connected, deeply connected.
All right. I'm following so far, I think. But can we get a real-world example in here? Something to, ground all this.
Sure. Let's say you're trying to figure out the area of a square, and each side is represented by 2 to the power of 3.
2 to the power of 3. Got it.
To find the area, you'd multiply side by side.
Right. Makes sense.
So you're essentially multiplying 2 to the third by itself.
Okay, I'm with you.
But instead of multiplying 2 by itself 6 times, which is what 2 to the 6th power is, you can just use that product of powers rule. Just add the exponents. 3 plus 3 equals 6.
Boom. 2 to the 6th. Way easier than all that multiplying.
Exactly. And less room for error, too.
So these properties are like shortcuts, but also they kind of reveal these like deeper relationships, right?
You got it. Now, I think it's time we tackle those terms you mentioned earlier, exponential growth and decay.
Yeah, those definitely sound a little intimidating.
Maybe a bit dramatic, but honestly, they're not as complex as they sound.
Okay. Yeah.
They just describe how things change over time. So exponential growth, that means something's increasing at an accelerating rate. Think of like bacteria. 1 splits into 2, then those 2 split into 4, then 8, and so on. That's exponential growth.
Okay, I'm getting a visual. Keep going.
On the other hand, exponential decay means something's decreasing, but at a slowing rate.
So it's not just going down, it's going down slower and slower.
You got it. Think of like a radioactive element. It decays really fast at first, then it slows down over time.
So it's like exponential growth is like a snowball rolling down a hill, getting bigger and faster. And decay is more like, a fading echo, getting quieter and quieter.
Perfect analogy. Now, there's one more thing in your notes we should touch on. Scientific notation. This is actually really connected to exponents.
I knew there had to be a connection.
So scientists use scientific notation to write out really big or really small numbers in a shorter way.
Because who wants to write out a zillion zeros?
Exactly. So think about the distance to a star, which might be trillions of miles. Instead of writing out all those zeros, we can use exponents, like 10 to the 13th power.
Oh, so that's where those huge exponents come in.
Exactly. And same goes for the size of an atom, which is super tiny. You might express that as 10 to the negative 9th meters.
So exponents are like a secret code for scientists to talk about all the, crazy big and crazy small stuff in the universe.
You could say that.
So to wrap things up, it seems like exponents are way more than just those little numbers hanging out above the line.
Definitely not.
They're key to understanding all sorts of stuff, like the area of a square or the distances between stars.
And how things grow and decay over time, those are pretty important concepts, too.
Absolutely. Now, here's a little challenge for everyone listening. Think about how information spreads online. Do you think it follows that pattern of exponential growth? Or how about memories? Do they fade away like exponential decay? See if you can connect what we've talked about today to the world around you.
There's always something more to explore.
That's right. And we'll be back soon to dive into something new. See you next time.
See you then.